This tutorial video is to help you out with some characteristics of a parabola. Now, the first things first, I want to make note of what a parabola actually looks like. This is a quadratic function that is graphed, so it looks like a parabola. Now, if there are any straight lines, this wouldn't be considered a parabola. It has a curved shape to it, like a U shape. If it goes like, it always faces either up or down. So if you have an arrow that's going up this way, and then it goes down, and then it curves up again, and then it goes down again, that is not a quadratic function. That would actually be a completely different function that you'll see later in your schooling. A quadratic is not a straight line, it's not a wavy line, it's a U shape that opens either upwards or downwards. Now, there's a few things that we can look at on this graph to determine like what the characteristics are so that we can describe it. So the first one is we can look for the vertex. So the vertex on this graph is going to be 2 in the x and 0 in the y. We move 2 over, which is the horizontal axis, the x-axis, and we move up to 0. So I can write that as a point. Don't forget your brackets, please, that we went over 2 in the x and 0 up in the y. And I'm just going to write x and y here so that you remember. So that is my vertex. My x-intercepts are any point where the graph crosses the x-axis. Now this graph actually only touches the x-axis once, but sometimes parabolas will cross the x-axis twice if they're lower than the x-axis, and sometimes they won't cross the x-axis at all because maybe they're sitting up here. But this one is touching it once, so I am going to put that the x-intercept is at where the vertex is, 2, 0. Now the y-intercept is where the graph crosses the y-axis, so you see that's that point right there, and that is at 0 in the x and 1, 2, 3, 4 in the y. So I would write 0, 4 is the x-intercept because it crosses at the 4, that's the y value. This parabola has a minimum value because it opens upwards. There is no number that's going to be less than this particular y value, this vertex point. It does not have a maximum because it doesn't open downwards. If it opened downwards, then it would have a maximum. So this has a minimum value. The domain of this graph is always x is in the real numbers. Because this graph continues on infinitely in both left and right directions, that means, or positive and negative directions, that means that x could be any number possible. But the range is a little bit different. The range, which is represented by y going up and down, has to be greater than or equal to this minimum value, and that minimum value happens to be 0. If the parabola had a minimum down here, then you would have a range of y is greater than or equal to 2, but our graph stops here at 0. So y is greater than or equal to 0. If you have a minimum on your graph, your range is going to be y is greater than or equal to something. If you had a maximum on your graph, you would have the range of y is less than or equal to something. So this symbol would look like this instead. All right, so those are some of the characteristics of the graph. The one last thing that I'll point out that's really obvious and always really helpful to us is the axis of symmetry, which passes right through the vertex. It's always represented by an x equals equation. So I'm going to write axis of symmetry here, which is x equals the number that it passes through, which happens to be in the vertex already. That's the x value there. So x equals 2 is my axis of symmetry. That x value is always going to match the x value in your vertex.